All right, my dear children of class 11 science, now we move to the next topic, the important topic from this chapter, kinetic theory of gases. Okay, so we discussed in detail about kinetic theory of gas, and related to kinetic theory, there are so many terms and the other factor that we need to discuss also. Okay, and you know the word kinetic means motion. The word kinetic also related to what? Motion. Now the theory of gas, when I use the kinetic theory of gas, is the constant random motion of the gases. The constant random motion of the gases. Okay, as you know that when we go through the properties of gases, and this property of gases can be explained on the basis of kinetic theory of gas. Okay, property of the gas is explained on the basis of kinetic theory of gases. Properties means like gases are the molecules of gas are always in the constant random motion. Okay, the molecules of gases are very far away from each other. Then there is less intermolecular force of attraction between the molecules. Okay, gases are highly compressible. Okay, so that means there are a number of properties that can be understood based on kinetic theory of gases. According to this theory, that is called kinetic theory of gas, every gas, whether it's a real gas or ideal gas, is made up of minute particles called molecules. Okay, every gas is made up of minute particle called what? Molecules. And all the molecules, remember this part, all the molecules of a pure gas are identical with respect to each other. That means they are identical in shape and their size is also what? Similar to others. That means all the molecules are identical with respect to each other. Okay, so this is one of the important points under kinetic theory of gas. And the gas molecules are at large distance apart from each other. That means that the separation between the molecules, okay, is usually large as compared to solid and liquid, as you have learned it. Okay, that means the intermolecular force of attraction will be least. Because when the space between the molecules is very large, then attraction between the molecules is almost very less. Okay, so that is the case that the gases, okay, have no definite shape and no definite what? Volume. So, if the space between the molecules is large, then most of the space in a gas is all empty. That means if the molecules are at large distance from each other, then that space where the molecules are usually at large distance from each other is usually a what space? Empty space. That's why children remember this. Most of the space in a gas is usually what? Empty. So, this is also one of the important points for kinetic theory of gas. So, every molecules of the gas, children, are in a state of motion, and when they acquire motion, they move rapidly because the space is large, the intermolecular force is what? Less. So molecules will not find more obstruction and more force experienced when they are in a state of motion. That's why the molecules of the gas are moving randomly. They move randomly in straight line in all possible direction in this what space? Empty space. So when the space will be empty, most of the space of the gas is empty, so that empty space is utilized by the molecules to move rapidly, okay, in the straight line, and all the molecules move not in the same direction, they move in all the possible directions. That means their motion is usually a what motion? A random motion. And children, you know what happens when the motion acquired by the molecules of gas is random? So in random motion, definitely one molecules collide with another molecules. Not only two molecules collide each other, but the molecules also collide with the wall of the what? Container. Just showing you a diagram out there. Okay, consider this is the wall of the container. Okay, comprises of what? Gas. So this is a gas filled in a container where the molecules, they are the molecules of the gas which are moving randomly in all possible what? Direction. So if molecules are moving randomly in all possible direction, these molecules will collide with the wall and again it change the direction. One molecules can also collide with another molecules. Yes, this can also happen. These molecules can collide with the wall of the container and change the direction this way. These molecules can go this side. These molecules can go this side. These molecules can go to this side. That means whatever molecules that are in the state of motion, they acquire random motion, and once the random motion takes place, then collision between the molecules can take place. But every molecules can have a possibility to collide with the wall of the what? Container. So molecules collide with the wall of the container as well as the molecules have a collision with each other. And you know what happened when the collision takes place between the molecules and the wall of the container? After the collision, the speed and the direction of molecules can continuously changes. So usually what happens? These molecules are in a state of constantly random motion. And during the motion, they collide with each other. And after the collision, the speed and the direction of the motion of these molecules continuously changes. So let me just add the point after the what? Collision. After the what? Collision. The speed. Okay, let me just write the point. Speed and the direction. Speed and the direction of molecules continuously changes. Molecules continuously changes. Okay, in all possible direction. In all possible direction. In all possible way. We can write all possible way. So this is the main observation that we see under the motion of the gases, and this motion of the gas means nothing but kinetic theory of what? Gases. Now next part that we need to keep in mind, children, under this concept of kinetic theory of gas is the pressure exerted by the gas. See, pressure can also exert by the gas. Now as per the kinetic theory of gas, pressure due to the gas is actually due to the collision of the molecules of gas with the wall of the container. Means when the molecules of the gas collide with the wall of the container, okay, there is a generation of pressure, development of production of pressure takes place on a gas. And this pressure, as I said, is actually due to the collision of moving particles or molecules on the wall of the vessel or wall of the container. Means when molecules collide with the wall of the container, okay, due to the collision of molecules with the wall of the container or vessel, the gas molecules exert what? Pressure. And if any one molecules collide with the wall, okay, after the collision, after the what? Collision with the wall, that molecules return back. It will return back. And when the molecules, whenever the molecules collide with the wall, it return with a change momentum, because motion acquired by the molecules with the collision of the wall acquire a momentum, and when after the collision what happen? The momentum of the molecules will what? Change. And equal momentum, the momentum of each molecule change, but that molecules transfer equal momentum to the what? Wall of the container. And transferring momentum to the wall of the container or wall of the vessel means, as we follow the what? Law of conservation of momentum. And this can be understood with the help of Newton's law of motion. And children, according to Newton's law of motion, you have learned that the rate of change of momentum, okay, of the wall is equals to the force exerted on the what? Wall. Means colliding molecules with the wall means molecules are exerting force on the wall. And due to the force exerted by the molecules on the wall, the momentum will change. And this rate of change of momentum is actually equals to the force according to Newton's second law of what? Motion. But children, it is not only one molecules that collide with the wall of the container. There are large number of what? Large number of what? Gas. A large number of molecules present in a gas. They continuously, repeatedly collide with the wall of the vessel or wall of the container. So when they repeatedly collide with the wall of the container, they exert a force on the wall. They exert a force on the wall. And this force is actually given by the rate of change of momentum. The rate of change of what? Momentum. But this rate of change of momentum is the average rate of change of momentum. Because out here, all the molecules does not move with the same speed. Okay, they move with a different speed. So, and all the molecules, when they collide with the wall of the container, exert a force. Okay, and this force which they exert on the wall, okay, is the average force of all the molecules. And due to this force, average force, there is an average rate of change of momentum. And this force measured per unit area of the wall is actually the pressure of the what? Gas. Because children, you know that pressure means force by area. See, pressure means force by area. So when molecules exert force on a given area, and that force exert on a given area exerted by the molecules of the gas measure the what? Pressure. That's why pressure can also be measured when the molecules are constantly in a random motion in a vessel. So pressure is measured by force by area, and this pressure is basically measured by the unit Newton per meter square, or we also call as Pascal. And Pascal is the SI unit of what? Pressure. Okay, but remember this pressure, which is due to the pressure exerted by the gas, is due to the force exerted by the molecules, which are constantly in random motion and collide with the wall of the what? Container. And this force which exerted on a given area measure the what? Pressure. So in this way we can even measure the pressure of the what? Gas. Okay, but gases are two types. One is a real gas, one is called ideal gas. But out here, when we derive the expression of pressure, we basically derive for what gas? The ideal gas. Now we go to the next topic, and basically in the next topic we talk about the postulate of kinetic theory of gases, and that you learn in the next YouTube video.